force like gravity. Gravity pulls you down to the ground so you don't fly everywhere.
And magnetic force pulls
you away from
pull something. Okay, keep reading.
Magnetic field is strongest near the magnetic pole. The strongest near a magnet. All the magnetic and magnetic field is strongest near the magnetic pole. Magnetic field is weaker farther away.
Okay. Next section. Sydney, go ahead and read.
Did you know our planet is a giant magnet? Most of the inside of Earth is made up of metal iron. The iron creates a magnetic field that surrounds our planet.
Oh, so let's think about this for a second. Our planet Earth is a giant magnet. I wonder if that's what causes, which is called what?
gravity.
I wonder if that's what causes gravity. What do you think about that, Bethany?
Yeah, because the ground is kind of like it's metal, like it's tapped with iron on the ground, and then it's kind of like we're the temporary magnet.
Okay. If you look over here at our little diagram, it says Earth's magnetic field is strongest at the poles. This is where the field lines come together in this diagram.
So is the North Pole
That's the poles of our Earth. And the core of our Earth is like a magnet. So it's constantly pulling everything down, which is what? Gravity.
And it's like that we're the it's like they're the Earth is a magnet and we're the metals and they just pull us down.
Kind of like that magnet right there that's behind you. It has like how it over here. These are the two. This is the South Pole, and this is the North Pole, and then the middle part. It makes it pull. It like because it's in the middle. It's like the whole thing makes a circle. It's like a circle and a magnet. In the middle, it's kind of like the Earth is your whole magnetic field, and it's like you're the temporary magnet, and you're sticking to the ground.
It's like we're little iron little shapes that you can put onto a magnet and it just picks us up.
Right. All right, Sydney, you want to go ahead and finish reading there? Finish this up.
Long ago, people noticed that one end of a magnet turned to point north. They called this end the North Seeking Pole. The other end was named the South Seeking Pole because it pointed south. Today, those names are short to just North and South poles of a magnet.
All right. How could you use a magnet to find the North Pole?
You could. I've heard of this thing where there's this kind of looks like the S, and it's like this, and it shows like numbers of the magnetic attraction and the magnetic field, how close it is.
Okay, that would be a very scientific device that probably none of us would be able to get our hands on. However, something you might have seen or heard about, what about a compass? Has anyone ever seen a compass? Yeah, it's like a little round thing, and it has glass, and it has a little metal needle in it, and it's labeled north, south, east, and west.
And it tells you which way you're going.
Right, and you can hold it up, and where is the little metal pin always going to point to? The North Pole. So, how could we find the North Pole? We could use a
Compass.
Yes. And why does it always point to the north?
Because you're probably it can point other
Because that's
directions.
where the magnetic force is the
Strongest.
Alright. Now, what about if our Earth is like a magnet, why doesn't it pull other planets to it?
Because the other planets could be like, well, let's say this is a magnet. It's like
But we're not magnets, and it pulls us to it.
It's kind of like it's not in the magnetic field.
Hazel?
It's not close.
They're all like Earth is one magnet and the rest of the planets are other magnets.
Okay. Camden, say what you just said again.
Like because the magnetic field is only like around Earth and it's not around the
What
other
is
planets.
that called? Have you guys ever heard of Earth's?
Atmosphere?
Yes, Earth's atmosphere. Our magnetic force is only strong enough to reach inside of our atmosphere. It's not strong enough to go outside of our atmosphere.
Because whenever you have two magnets, if they're too far apart, they won't attract or repel.
If I hold up this magnet and Sydney holds up a paper clip, is my magnet strong enough to pull the paper clip out of Sydney's fingers?
Like it says
No.
Not for my
But if I did it right here, would it be strong enough?
Yes.
Yeah, it would
Because
be strong enough.
all the
So
other
it's kind of
planets
like
are
that.
spread out, and it's like the other planets are like copper. So
Right,
it
if
won't
this
attract
is
them.
Earth right here, and this all the way around it is the atmosphere, it's strong enough to provide gravity to hold us to Earth, but it's not strong enough to go outside of our atmosphere and pull other things in. Okay?
kind of like say if you got a paper clip like and you put it this far away from the magnet, it wouldn't stick because the magnetic field isn't big enough.
It's not strong enough,
Like it says right here on page 354, it shows that's only Earth's magnetic field and it doesn't go all the way around.
Right, you can look at that diagram and you can see that it's strongest at the poles, and that's the field, and it's weakest when you get farther away. Yes. Hazel, do you have anything else you want to add?
I was thinking, like, since we're, like, so say Venus is at the south of us, like at the south pole.
Yes.
Like, near to the south pole. And so it's north, well, I mean, it's south is facing our side. It might, it might be pushing against us.
Right, but it's not close enough to our atmosphere to be close enough to our magnetic force. Okay, right now we're going to watch the brain pop video. I know you guys already watched it to review or to kind of give you a preview. So we're going to watch it now, and then whenever we are done, we're going to do the brain pop quiz. And then tomorrow we have our magnet experiment centers, and then you probably will have a quiz over magnets on Thursday, depending on our schedule. So, all right now we're going to watch the brain pop quiz or the brain pop video, and then we will do the quiz.